Bengaluru is India's tech headquarters, moving data in milliseconds. Yet for years, its physical infrastructure brought that digital momentum to a complete standstill. This was most evident in western Bengaluru. On the corridor between Mysuru Road and Magadi Road, the traffic was a dense mix of heavy freight trucks, office commuters, and emergency vehicles, all forced onto the same narrow, overcapacity streets. Although the physical distance between Chalagata and Magadi Road is short, the density of the existing network meant this single stretch could routinely take 60 minutes to cross. This delay represented a massive drain on the city's resources. It cost lost workplace productivity, higher fuel costs for every driver, and increased local vehicle emissions. The physical gridlock acted as a persistent friction point, limiting the efficiency of the very industries the city was designed to host. In many expanding cities, the immediate solution to traffic is to widen the existing roads. In western Bengaluru, the math didn't work. Decades of rapid development meant that residential and commercial buildings were already packed tightly against the current road edges, leaving absolutely no physical room for any expansion. Solving the problem required moving beyond the existing grid. Planners realized the only way to manage the volume was to carve out an entirely new, massive arterial corridor designed specifically for high-capacity transit. This required a system built for long-term stress, an intervention designed to handle the projected traffic requirements of the next several decades. The result is the Krishna Road. It is a 10.7-kilometer, 10-lane major arterial highway, providing a high-volume transit link across western Bengaluru. The road is named after Krishna, who served as the Chief Minister of Karnataka from 1999 to 2004. During his term, he focused on the modernization efforts that initially established Bengaluru as a global IT hub. Naming this high-capacity corridor after him acknowledges his role in the economic growth that eventually necessitated this level of infrastructure. Constructing a 10-lane highway through an established metropolitan area presented significant challenges. Engineers had to work around active residential zones and busy intersections, all without halting the city's daily movement. Construction teams had to navigate complex underground water lines and electrical grids. At the surface, they managed to raise massive concrete supports and scaffolding, while civilian traffic continued to flow through the site. Simply adding lanes doesn't solve congestion if vehicles are still forced to stop. The primary engineering goal here was the systematic removal of stoplights and choke points. Horizontal engineering keeps traffic moving. Service roads physically separate local vehicles, entering or exiting neighborhoods, from high-speed central lanes. Vertically, flyovers allow vehicles to arch directly over major intersections, maintaining continuous flow without signals. Engineers also integrated modern drainage systems to handle the heavy monsoon rains that typically cause seasonal flooding and gridlock on standard city streets. Along various stretches, the project includes infrastructure for non-motorized transport, such as safe pedestrian walkways and dedicated cycling lanes. By creating an environment where a single vehicle can move from one end to the other without stopping, the road effectively buys back 45 minutes of a commuter's life. The impact on the clock is immediate. A journey through western Bengaluru that previously took 1 hour is now completed in approximately 15 minutes. This restored flow results in immediate secondary benefits. Steady driving speeds lead to lower fuel consumption across the grid and a corresponding drop in vehicle emissions. The improved connectivity is also driving a shift in the local economy, as faster travel times encourage new commercial and residential property development along the highway. Krishna Road functions as a primary node in Bengaluru's larger mobility strategy. It is designed to work in tandem with major transit initiatives, including the Nama Metro expansions, the suburban rail network, and the peripheral ring road. Converting hours of gridlock into minutes of transit provides more time for businesses, more time for families, and more potential for growth.